Morning, everyone, and welcome to the second FORTIS webinar. I am Daniela Fonseca from F6S, and I will briefly introduce today's topic. So today we are talking about human-robot collaboration in the workplace environment, and we are talking about robotics and workplace environment and artificial intelligence that are no longer just futuristic concepts. They are already reshaping our workplaces, from construction sites to factories, different industries. The human-robot collaboration opens up new opportunities for us to improve safety, efficiency, and adaptability. But of course, it also raises some questions, such as how can we build trust between humans and machines? What kind of regulations and policies do we need to put in place to ensure an inclusive collaboration, as well as to ensure safety? And how we make sure that technology enhances the human work instead of replacing it. So these are some of the key issues that we will explore today in our session for human-robot collaboration in the workplace. The webinar will run for 1 hour and a half with presentations from our invited speakers, followed by a moderated roundtable discussion. It is now my pleasure to present to you our moderator for today. This is Professor José Palma Oliveira. He will guide us through today's presentations. Professor José Palma Oliveira is a part of the FORTIS consortium and FORTIS project. He's actually a professor at the University of Lisbon and internationally recognized for his work on risk, environment, and human behavior. He has served as past president of the Society for Risk Analysis in Europe and has been a fellow since 2012, and in 2016 received the Society's Presidential Merit Award for his humanitarian and scientific contributions. He is also a distinguished visiting scholar at the University of Virginia. So as you can see, he has contributed extensively to the environmental and risk policy at national and EU levels, and also worked as a consultant internationally in Portugal, Tunisia, Brazil. So his research and practice focusing particularly on resilience, risk communication, and how societies adapt to change are important factors for us to have him on board today. We are honored to have you, Professor José. Thank you so much for joining us, and I'll give you the floor. The floor is yours.
Thank you very much for your kind words. Okay, we have three incredible speakers today. And instead of presenting them in sequence, I'll introduce the first one and then go to the second and the third one. The first one is Professor Alexandra Schiotti, that is a senior researcher at the Italian Institute of Technology, where she leads the contact unit. She's internationally recognized for her work in human-robot interaction and social cognition, with over 100 publications. The talk is Building Trust and Human-Robot Collaboration, Insights from Social Cognition. Please, Alexandra, the floor is yours.
Thank you. Thank you very much for your kind introduction. Let me just share my screen. And please let me know if you are properly seeing my presentation.
Now we are okay.
Wonderful.
Please do it.
Thank you very much. So today I would really like to talk about our let's say our analysis in relation to how to build a proper relationship of trust with robots that are collaborating with us. Indeed, I lead the Cognitive Architecture for Collaborative Technologies unit at the Italian Institute of Technology, which is really a unit dedicated to try and use robots as a way to best understand how we humans are so good at interacting and collaborating with each other, with the ambition of transferring some of those models also onto our machine to make them better collaborators. And one thing that we realized in our research is that one of the biggest barriers in establishing a proper and effective collaboration between humans and robots is often the cognitive incompatibility between the two agents. The fact that we look at the world and we understand the world, humans and machine, in a very different manner. So if on one hand, machines are designed to be very accurate, precise, and detailed, on the other side, humans are much more projected into the future, which is the positive side, but sometimes also base their judgment on factors that are not quantifiable. So they depend on both perceptual and cognitive biases. So if we want robots that are really good at helping us, we really need to make them considerate. So we really need to endow them with models that allow them to understand how humans understand and perceive things. And this is particularly true in the context of trust. Indeed, if we see how trust toward, in general, automation has been described in the long year past, we know that it depends on factors such as the performance of the machine, whether the machine is transparent in terms of how it is functioning, and how reliable it is. But if we look at how we formalize our trust toward other people, the picture becomes much more complicated, because the way we trust other humans depend also on social norms, on social influence, factors such as reciprocity come into play. So how do we deal when we are collaborating not with humans, but with robots? Where our trust building position itself in this continuum between trust toward automation and trust toward other agents, such as humans? Well, the question is challenging because there is already this very old seminal work by Robinet et al. That shows that whenever we are asked to trust a robot, we might tend to overtrust it. And he presented this nice work in which he recreated a sort of emergency scenario in which there was a fire emergency, people had to escape, and around there were the proper indication of a fire exit, but there was also a robot. And the robot was showing the way out. And interestingly, they manipulated how accurate the robot behavior was. And they even presented the robot clearly malfunctioning. And what they found out was that despite the overt malfunction, a lot of people actually trusted the robot and not the written indication. So this opened up the question on whether our trust toward robotics actually follows the rules of trust toward automation. So if we really base our decision on the actual reliability, transparency, and performance of the robots. So we wanted to put it at test in a way that we could control the scenario more properly, and we designed an experiment in which we used a totally different robot, a childlike, which is a humanoid robot called iCub that we use in our experiments, and we recreated a scenario that was not dangerous, but that allowed us to investigate the building of trust. So it was a treasure hunt, a game, in which the robot offered itself as a helper for the participants. So participants could go there, touch the robot, and receive hints about where to look for hidden objects. There were a few hidden objects in a room. You could ask for into the robot, and if you could find all the objects hidden, you would receive a monetary prize. Interestingly, at the end of your chase, the robot itself, with no experimental suggestion before, told the participants that there was an additional hidden objects in the room. And so if they were trying to find it, the participants, and found it, they would have doubled the amount of money won. Otherwise, they would have lost everything. And the robot itself was suggesting them to try and gamble the winning. We wanted to see whether this influenced the selection and the choices of participants. So we welcomed several participants into the game, and we found out that their attitude toward trusting the robot were very different at the beginning. Some people played by themselves, some people relied a lot to the robot from the start. But what we noticed, and was common across everybody, was that despite the very short interaction, it was 30 minutes, we saw a significant increase in the reliance toward the robot. So people increased their amount of help requests, they conformed to the suggestion of the robot. This means that if they were looking for some place, they then followed the suggestion of the robot to select the next place, and also they came back to the robot to ask once more. And also looking at proxemics, so how close they went to the robot, we noticed a significant decrease of distance over time after interacting with the robot. Interestingly, when we went to see the exploitance or exploitation of trust, so whether people actually decided to gamble what they won during the game, we found out that among those who actually managed to finish the game, 100% decided to gamble. And when we asked them why, a lot of them justified their decision also based on the fact that the robot suggested them to do that. So that was interesting because it told us that even a very short-term interaction with a robot can have significant impact on the building of trust-related and reliance behavior in humans, even to those that were a little more risk-averse. On the other hand, this seemed simple because in a sense, the robot was providing correct hints, so why not to trust it? So we wanted to increase a bit the difficulty of the task by showing a robot breaking. So still giving hints, but clearly malfunctioning. So we created actually a lot of series of different possible malfunction in terms of how the robot moved. It even crashed at a certain point. And we validated among multiple crash that we created online how much participants who had participated in the real game before would have considered that worrisome. So we asked them, oh, if this happened during your game, how obstructive you'd feel this failure to be, and how do you trust robot after this failure? And participants online told us, oh, this particular crash, well, I find it quite obstructive, or hey, this would reduce significantly my trust. So we picked the ones that were more terrible in sight of these virtual participants, and we implemented them. And we replicated the game again, this time with 68 participants who played the treasure hunt game, this time with the robot crashing every now and then. And we also separated that into group. One group just observed the robot crashing. One other group observed the robot crashing, but after the crash, the robot said something like, oh, sorry, my motor broke for a moment, or my sensor broke for a moment. We did this transparent condition because in trust toward automation, we know that transparency actually increases trust. So it should have mitigated the damage given by the failures. And the most interesting result that came out from this is that then after the experiment and participants managed to play the game and everything, we asked the same question that we had asked online about trust and obstruction. And we found out a very different result. So people who actually played with the robot didn't care about the failures. They really didn't find it as obstructive. They didn't modify substantially the level of trust toward the robot. So the fact that the robot was not reliable in terms of functioning, that its performance was low, did not reduce substantially the trust of actual participants, despite people thinking of it and seeing it online had thought so. Moreover, comparing the transparent condition with the non-transparent condition, we found out that transparency was detrimental. So participants who received a little of explanation of the robot about the failure actually reduced more their trust into the robot. So overall, this little experiment showed us a very clear point that in the context of human-robot interaction, and that was an actual collaboration, the robot was providing help to complete a task, the dimension of performance, transparency, and reliability were not good predictors of how much people were trusting, especially when they were actually collaborating with the robot and not reflecting about it online. So we said, if these factors do not influence trust as we expect, maybe we should consider those who we know apply to humans. And so we created a more controlled experiments to try and investigate social norms and social influence in the context of human-robot collaboration. This time the game was much, much simpler and more similar to a precise task. So we showed 2 dots on a screen to a certain length, and we asked the participant to reproduce the length by touching on the touch screen. A very, very simple length reproduction task. And we chose that because we know that we humans have a problem in that. There is a bias, a perceptual bias, which is called central tendency, and we underestimate longer distance and overestimate shorter one, and we are not aware of that. And we perform this task in a collaborative manner. So I, as a subject, give my answer. So I think this is the length. Another agent, the robot, gives its own answer. And then either I or the robot decide the final answer. So we can see whether I changed my opinion as a function of what the robot suggested me. And we compare 2 conditions, a condition in which the other agent was a robot in another room touching the touchscreen, or a computer on 50 participants. Interestingly, I have to say that we created a very good agent, a very good robot. So here you see the average error that participants did, the human participants in yellow and green, and the average error that our agents did. As you see, the robot and the computer were really much better than the participants, our agents. So in theory, humans should have totally trusted the suggestion of the other agent. Then we went to measure how much participants changed their opinion as a function of the suggestion, the hint by the robot or the computer. And we found out the first interesting result. Despite the algorithm that provided the answer was exactly the same for the 2, participants trusted more the robot, with exactly the same performance. Another interesting aspect, though, was that with this particular design, we could measure 2 types of trust. One trust is the explicit trust. So I say that it is this long, you robot say that it is that long, and then I take the final decision. And you robot see me. So how much I change my decision as a function of your suggestion is a form of explicit trust, because you see what I do. But there is also an implicit trust. Since you agent, you robot, you're actually better than me in performing the task, if I trust you, I'll learn from you. So my error will go back over time. And so I can measure both how people explicitly trusted the agent and how much instead they actually trusted it. And if we look at the computer condition, when people believed to interact with the computer, we see that both factors go in the same way. So I both change my mind to follow the computer overtly, and I learn from the computer. I actually made progressively less error. With the robot, the picture is totally different. Indeed, what we see is that with robots, participants showed as if they were trusting the robot very much, so they changed their overt opinion, but didn't learn anything from the robot. So actually, they were not trusting. They just didn't want to disappoint the robot in some sense. So this means that if we are thinking of collaboration and imagine also a training scenario in which a robot is actually more accurate in its perception and could provide good suggestion and training to the participants, we have to be aware that the way humans encapsulate and models the suggestion of robots, well, it's different from suggestion of machines or computer and might be interfered with some of these social norms or worry about disappointing the agent. So when we are programming it for collaboration and training, we need to be aware of that. Of course, this was a very simplified, clean experiment, if you want, in which we didn't allow the robot to provide explanation. But we have a line of research in which we are investigating XI, so how to provide the most appropriate explanation to convince participants to follow the right suggestions of the robot. And what we found out in this case, we tried to explore two different explanations. So we created a robot that gave suggestion, in this case, to complete a game, the Connect 4 game. And we compared the condition in which it built counterfactual explanation based on all its prior knowledge about the Connect 4 game. So a very extensive knowledge of a game, as a robot might have. In a different condition, we performed exactly the same explanation, but they were not based on the full knowledge of the robot, but only on the subset of games that the robot had already played with that participant. So the participant saw the game, it proposed a move, and again, the robot was saying, I would suggest you to do this other move because it would be more similar, more appropriate given this current game. And then the participant could decide whether to follow the suggestion of the robot or not. And we compared the condition in which the knowledge of the robot was global and the condition in which the knowledge of the robot was based only on shared experience with that participant. So it was a smaller but more personalized knowledge. And what we found out is that in all cases, the explanations allowed the participants to increase significantly their victories. So participants could learn, indeed, from the instructions of the supportive robot. But the interesting, or most interesting to me, result was that the most persuasive condition was when the robot had not the full knowledge, but based their suggestion on the shared experience with the participant. This suggests us that when we build robots that could give suggestion and support to participants in collaboration, sometimes it's better to prioritize a personalized scheming of suggestion rather than a full and extensive knowledge. So this is just kind of research we're doing. That is our building in Erzelli, in Genoa. What we are trying to do now is to say, how can we make robots actually help in establishing mutual understanding and at the same time gauging the right measure of trust. And we believe that to do that, we need to leverage on the basic mechanism that actually allow us to establish trust and mutual trust with other humans. This is heavily based on how our brain functions and on all those signals that we exchange through embodied communication. So our first step is actually to investigate how we understand each other through nonverbal communication and enable the robot to make sense of those similar signals. On the one hand, being able to read them, on the other hand, being able to express them. On top of that, we are building both model-based and data-driven based approach to actually construct what we define as a cognitive architecture, so that the robot can not only communicate, act, and read the human, but it can also build shared experience, so accumulate memories through effective and continuous interaction with the partner, so as to be able over time to learn and combine this basic knowledge about action and perception to specific and personalized knowledge about the human needs, desires, necessity, and specificity, as each of us is different. And we are building, therefore, autonomous robots that are supporting this mutual understanding with humans. And we are also exploring the possibility for them to live not only the dyadic domain of interaction, but also interaction with groups that, as you may imagine, is even a more complicated task. One big component of that is, of course, trust, because when interacting with an autonomous robot, you have to negotiate the different responsibilities between the two. You're not commanding it anymore. The overall ambition of our work is to create what we define as more humane technologies, where humane doesn't mean that the robot needs to look like a human. We are using a humanoid because it's simpler for us for the investigation, but that is not necessary. Our ambition is to create robots that think like a human, so that they are aware of how humans perceive and understand the world and can adapt to that to be good collaborators. And this is the people who actually work with me and conducted all the research I discussed so far. Thank you for your attention.
Grazie mille, Alexandra. Thank you very much. Okay, now, after this very good for thought, if anybody has a burning question for Alexandra, we can do it. But since we are a little bit late, let's go to Isabel. Isabel Dor actually is an engineer with more than 30 years of experience, work first on basic things as thermal hydraulics, and then she dedicated herself, like partially myself, to European research initiatives. And now she coordinates a very interesting project that Ierashi, that actually is about robot-human collaboration. And then Isabel, I'm very happy to give you the floor. Thank you very much.
So thanks very much for the nice introduction, and thank you, Alexandra, for putting the work. So I'm going to share my screen first. Hope it works.
Yeah.
Okay. Well, I will more develop on a European project that's dealing with human-robot collaboration in the workplace and how to work with SMEs. So first, I'm giving a few words for the context. Then I will really shortly present the Arashi project and what was its main objectives, give a few hints about the challenges we had during this project, and just give you one example or two examples of project we selected, as a matter of fact, working with the startup and SMEs. So just to give you a context of this Arashi project, that's despite a strong decrease in the 90s, there are still 3.1 million non-fatal accidents at work that results in at least 4 calendar days of absence from work and around 3,300 fatal accidents in the Europe. All these work-related accident and illness cost quite certain billion euros to the Europe economy. All my figures are more around the 20s. For example, in France, we have 10 to 15% of accidents that are related to production machines, so more to the manufacturing world. That's this health and safety at work still is major concern for the UC, and that has proposed a new strategy framework in the 2015 on occupational safety and health to protect health, both physical and mental, both ways, on the almost 170 million workers we have in the Europe, and in order to achieve sustained decent working conditions for all kinds of workers. And all this health and safety at work and strategy framework, as we'll see, he's tackling three aspects of the transition, which is green, digital, and demographic. So this new framework that was defined by the EC defined three objectives, and the first one is really relating to being anticipating and managing change in the new world of work that what is brought by this green, digital, and demographic transition. And as we will see later, is more related to the workforce that is aging in all Europe countries, and for which the working environment must be very adapted to the fact that the working force is aging, so to their needs, and to limit all these musculoskeletal disorder. So what do we mean by the green transition? It's because climate change can affect safety and health, because the temperature and the air condition, and also the circular economy that results that's touching power consumption from the point of view, and as well recycling, refurbishment, and second use. And I think also something that we have to keep in mind is most of the industry in France in Europe is supported by small and medium companies, that some of them are very traditional and already have very old machinery that are still working. So I think we need to keep that in mind. The digital aspect is driven definitely by the introduction of robotization and AI and remote work that reduce risk of dangerous tasks, but and so forth increase the productivity, but at the same time also increase cognitive overload, digital fatigue, mental exhaustions, and various forms of techno stress for the workforce. So it leads, of course, to the development of new tools and machinery, such as collaborative robots, AI embedded in the machine, data dependency, but as well software update, connectivity, and cybersecurity also are topics that are addressed in this European Machine Directive. And as I originally mentioned, we have the demographic transition, because the workforce is aging, which implies adapting the work environment and specific needs to limit musculoskeletal disorder, but also to support the trustworthiness and the acceptance of these new technologies. So just where stands this ERASHI project, European project? So ERASHI project is fostering a human-centric and sustainable digital transition in manufacturing. And it's a Horizon Europe project that was started nearly 3 years ago and will end at February. And one of the specificities of the project is really to support startup and SMEs to uptake new innovative technologies. So it was what is called usually a cascade funding project or financial support to third-party projects. You just have a short line of the consortium. I just want to mention that it's mainly our classical consortium with research center, big industrials, university. We also have some cluster associations really to go deeper in the ecosystem, in the local ecosystem. We also have a SME Blue Morpho that is dealing with innovation, because really the objective of the project is to support the SMEs and the startup to go faster and more strong on the market. So we have to know if the market exists. And I will mention that the last one, which is Hervé, which is, as a matter of fact, is a lawyer, was not first part of the consortium, but appears to be very important to deal with data and ethics as soon as and acceptance and trustworthiness of this new technology as soon as you start dealing with robotics and AI. So just that's the ERASHI project to sum up. So the objective is really to improve working conditions, trust and acceptance of collaborative robotic AI in robotic system for the production machine tool sector. As a matter of fact, that is extended to manufacturing. So the objective is, as well, as I mentioned, to support especially startup and SMEs in the uptake of advanced technology, digital and eco-responsible technologies in that field. The target was really to help employees in their daily activities and improve their working conditions. Then, as a consequence, was leading to a productivity increase. And one very strong aspect of the project is a worker-centric approach by considering workforce, well-being and health design, thinking methodology of production machines, worker acceptance and ethics, and really to work with the SMEs. That really startup and SMEs are very much technological. They have very great idea. Then, of course, we ask them to consider the market and also then to consider this workforce and how this is going to be accepted. What will they need to do? How can they preempt this new of scenario? I will come to that shortly. Of what we did. So if I just want then and to sum up shortly about this, how we handled this cascade funding money, we just run 2 open calls to select 10 granted projects, as we had a funding per project around 200k euros. The objective, how the open call were set up, is that we were provided technology transfers through the RTOs and the academics. So it was mainly what I call the technological brick. So we had a huge catalog of technological brick where the candidate to the open call had to select a technological brick. And most important, and maybe that probably answer to your question, we had defined a series of 10 challenges with big industrials coming from all over Europe that consider as promising and very important challenges. So the way the proposal was built, that you had to provide to show that with the technology you wanted to develop, you were providing an answer to one of the challenges. So that was the way I would say the proposal was built. And just to highlight a little bit more, what we provided through the selected project, as I said, was coaching, business coaching, and there was very strong support about how to introduce and to deploy a human-centric approach in the development of your product, and as well the ethics aspect, digital acceptance, trustworthiness. So we defined, as I said, we defined 10 challenges, and these challenges, if I can try to sort them a little bit, well, 2 of them were addressing robotic assistance for repetitive tasks or heavy duty. One of them was targeting machine tool for recycling, refurbishing. One of the challenges was addressing worker stress monitoring and assistance. At least for more than one challenge, it was targeting the digitalization of procedures through different aspects, the automation of process, enhanced digital planning, AI-human collaboration. One challenge was directly supporting the development of the deployment of human-robot collaborations. And the last one, it was very interesting because it was one challenge our panel of industrials thought was very important, was the gamification of work tasks. And this was more related to try to attract new people and younger people to this manufacturing area, which might sometimes they were not really tempted because probably they think it's too traditional, not innovative enough. And interestingly, this was one of the challenges we had in the open call, and we nearly got no proposal targeting that open call. So obviously for technological startup and SMEs, it doesn't seem so attractive. And so it was a way this challenge were presented to the as through the open call. So we were trying to define the related pain point. We tried to describe the use case to see what were the associated challenges, because of course, usually when you answer to one challenges like robotic assistance for repetitive tasks, at the same time, probably you may also support worker stress monitoring decrease. But this was a way. So and we were proposing some example of existing solution. And then it was more dealing with the technical competencies they could they could support, the company could support through the through the Arashi project. So, just shortly, I'll skip this one. It's more just to give to obviously what kind of results we got, and this was, and then I more classified, the proposal that we have finally selected to the through open calls. So, and these are mainly 3 pillars: robotic assistance, what I call more generally environment digitalizations, and human well-being and workplace safety. So for robotic assistance, the project we selected, it's one is really dealing for heavy workload transportation for yard operation in harbor. So it's really meant to replace trucks moving from one place to another one, but trying to optimize with a small robot able to carry very heavy loads and to try to optimize. And instead of having drivers going from 1 meter to a couple of meters, to try to better organize and also as well to decrease pollution. One, for example, is mobile screw driving platform for both assembling and disassembling product. And one, again, the objective is really to replace the very most repetitive task in order to have the operator and the worker focusing on the most technical one. There is one which is about inspection. We got two about inspection, especially in the one you have to deal with wind tunnel blades that are very, very long. So they are more than 80 meters long. So it can be a very long process, but I'm just going to highlight in the next slides about it. About environment digitalizations, while it was many about to ease manufacturing process. One again, well, very much what's behind is that, well, you have some very repetitive tasks and you have to consider the added value of the work and the operator. And the objective is really to decrease the time to spend on something which is very much repetitive, and to keep the skills and competencies for the more tricky part. And in any case, when there was inspection, the objective was really at the end, the worker, the operator is really the one who takes the decision. So it's the robotization will provide support to try to save some time regarding that very repetitive basic task we know added value. And then we also had the one pillar was about human well-being at work and safety. Well, this is, well, for instance, one was really to monitor working conditions related to stress level and safety recommendations using, so this one was more about AI than maybe about robotic. If I just want to illustrate one of the projects, this Orion project, so it's really dealing with support for the wind blade inspection, to improve the inspection of wind turbine blades. That is a critical process that is very critical and very important in order to ensure performance and safety renewable energy systems. Just to give you an idea, it was the one example. One of these wind turbine blade is around 86 meters long, and if you want to run complete inspection as it was done now, it's more than 80 hours. And among that 80 hours, just a few of them are really critical. Most of them are very basic and repetitive tasks. So the objective is really to work. So we have here the kind of platform, the robot, and also to use to reduce, so as was said, to reduce user stress and workload in interpreting the data. So it's really to enhance the reliability of defect detections, and so it's really to integrate human expertise with AI and robotic to support decision making. And this is, for instance, some of the development that is currently on process. So it's just, this last page is just really to illustrate, you have the 10 projects that were selected, and the pictures tend to illustrate the application domain. So this one, for instance, was a heavy load in a port courtyard. This one is about the inspection of wind blade turbine. This one, and for was a quite interesting one because it's combining very innovative startups with more traditional company, which is an industrial bakery, and the objective is really to support the in terms of safety, just to control if well, to help the control that workers are really working all their safety suits, gloves, and they are working in the right position and in the right place regarding all the machinery along the staff. So and here there are more, and this topic are more sorted in terms of challenges. So this one is the automatic screwdriver I was mentioning. Is about, so it's about mobile robotic assistance for very repetitive tasks. This one, challenge 2, is more about robotic assistance for more heavy duty. This one is more about digitalization of product. This one is it's in between, so it's target the automation for optimization of intra-factory logistics. Here's more human supervisors to solve complex problems. In many of these cases, of course, you have always collaboration with AI and AI. And just to come back to that, it was very interesting to work with the SMEs because, as I said first, AI data regulations were not so much in the set of mind of the developers, maybe more other users, but not of the developers. And really, one of the objectives of the project, interesting part, is to make them take into consideration how they will be accepted, the trustworthiness, and how to work with with them to give them at least the first rules how to work with that and how they have to implement it in their project, because at the end what they are trying to reach is really the market, so this will need to be fully accepted. Okay, that's all shortly and fast what I wanted to say.
Merci bien, Alexandra. Isabella, pour to be able to, in such a short amount of time, to describe a lot of projects, that was really fascinated. Again, since we are a little bit late, if we don't have any burning question, I would. Okay. I have one burning question for Isabel. What are some examples of scenarios that you work on?
So, for instance, there is one of the project is meant to develop. No, they have robot, but really the one of the objective is how, if you have a robot in kind of traditional company like painting company, then you need to have robot that, well, you can change what they need to do, but very easily. So it should not be all software and hardware behind. So they are developing a process so that you can teach easily the robot that's with working with the operator. What do you, if you need to paint such kind of panel, for instance, which kind of movement needs to be done? And in that case, they are developing the process that the operator can work, of course, was to teach the robot what are the gesture he has to need to process the task, for instance. So this is a place where it's for very basic, for instance, panel. So it's the way is really, well, you need something which is easy to handle because, well, when again, it's kind of traditional industry. So it has to be easy to be handled by the operator and the worker. So this is one of the example where it's really human collaboration to teach the robot how to do simple work and then to keep the experience of the operator for the more tricky work. One again, considering that the working force somehow is aging and, well, and it's really something that we get every time. It's, while we also have to consider that the workforce is going to decrease. So we have to, how can we consider it? And, but there's always a concern that you have to, I mean, all the workers we have now have skills, competencies, and we need to keep that, and we need to make sure that this is what is transferred to the younger generation.
Thanks very much. Okay, we want to have an open discussion, and myself, I have some specific questions that we're gonna discuss at the end. Now, if I may, I'm gonna give the floor to Ioannis Anifantis, is actually a senior research project manager at OSHA, and is an expert on risk assessment, digitalization, safety technology, and emerging risks in the workplace. And we are looking forward to listen to your presentation, Ioannis, and thank you very much for accepting our invitation. The floor is yours.
Thank you, Jose, for the kind introduction. My name is Ioannis Anifantis. I work as a research project manager at OSHA, and in my presentation, I'm going to present you the OSH perspective in terms of occupational safety and health and the automation of tasks. A big research overview study that we started several years ago at OSHA, and also it's the topic of our current campaign. OSHA, for those of you who are not familiar with, is an EU agency, one of the decentralized EU agencies established in Bilbao, Spain. And it's the agency responsible for the collection, analysis, and dissemination of relevant information on occupational safety and health to all the different stakeholders in order to have healthier, safer, and more productive workplaces. In order to achieve that, we conduct a number of research projects, we develop tools, we conduct surveys, but also we run a Healthy Workplaces campaign every 3 years on a different topic. And the area of digitalization on which we have started working several years ago was identified to an area as an area that doesn't present all the traditional risks that are relevant to occupational safety and health, but there are a lot of new and emerging risks when it comes to having workers working with digital technologies, with automations, collaborative robots, humanoids, and all these things. Based on a survey that we conduct every 5 years, and these are the findings from the latest version of this survey, which started back in 2009, we can see that more and more workplaces today are using digital technologies. And actually, in our very latest version, it was found that only 4% of the establishments are not using any digital technologies today. And more and more in the enterprises, we can see that there is a discussion about the impact of those digital technologies on occupational safety and health. So from our side, our participation in seminars and workshops and conferences like this, because of our role, it is to supporting these kind of initiatives and projects, because introducing these safety concerns since the design and implementation phase was found to be the most effective way of dealing with occupational safety and health. More and more also automations and robotics are introduced in the industry, and we can see that there is an increasing trend of machines incorporating artificial intelligence and also interacting with workers. But all these technologies have found to have been found to have several implications for the safety and health and of workers, and there is an increase in reporting specific risks, risk factors like reduce of autonomy, like it is reported that new technologies tend to determine the speed of work of workers, increase the feeling of surveillance, increase workload, or influence the work pace and the processes. Specifically, when it comes to robots interacting with humans, it has been reported that there is a tendency and a perceived increase in time pressure, job insecurity, poor communication or cooperation, and longer or irregular working hours have been reported. To that end, we started a study, a big overview study, actually more than 6 years ago on the area of digitalization, and we highlighted different areas. One of these areas was the area of automation as well. And when we started discussing about this topic, we identified that this task-based approach would be the most effective to follow. Given that every job consists of specific tasks, some of the tasks are the most boring, the most dull, dirty, or dangerous tasks, while there are also some more creative parts, tasks, and ideally the technology should be able to automate these dangerous tasks, and the most creative part should be left for the workers. And apart from this main categorization, these tasks could be either physical, that required physical manipulation, or cognitive. And in order to have a research that actually would be valid for the following years, we thought that it would be a good idea to develop somehow a taxonomy in order to be able to categorize all the different solutions in the market during that time in different categories and identify the implications for occupational safety and health for each one of those different categories. Think that our study started back in 2020, and many of today's technologies and applications and solutions like generative AI and things didn't even exist by that time. However, specifically because of this taxonomy that we have developed, we still manage to somehow categorize all the different technologies today and be able to identify the different challenges and opportunities also for occupational safety and health. So initially in our study, we identified the main sectors in which these technologies are used, and we presented some examples for the automation of tasks, while we also developed a number of different case studies referring to specific solutions used in workplaces in Europe, but also outside Europe, and developed a cartoon-style representation for each one of these solutions because our target audience is quite broad and wide. We are addressing these findings to policymakers, workers' representatives, employers' representatives, safety officers. So we need to have some material in order to raise awareness to many different stakeholders and different levels of expertise. So in one of our case studies, for example, we developed all the background and the framework regarding a case study for a vehicular automation, an excavator that can actually dig trenches in an automated way. This is some hardware and software installed on the system. So instead of having the operator in the excavator, the operator could be outside the excavator, or even the whole machine could work in an autonomous way. And using geo-fencing system, it could work autonomously, having the operator in a protected, let's say, environment, just supervising the whole procedure. And a number of opportunities were identified for this, like reduction of physical workload and health, or prevention of accidents, upskilling, attracting new workers to the industry since these kind of digital technologies were used, but also a number of challenges for occupational safety and health and risks, like the mental workload. They need to have all these people trained again, and some upskilling that should be performed that could increase stress on one hand to the operators, the fear of job loss, but also the issues of cybersecurity. And all the different implications for occupational safety and health were categorized in three main categories: the physical, the psychosocial, and the organizational dimension. And trust was identified as one of the main areas that should be considered when it comes to occupational safety and health. Because all these different sub-dimensions like job demands, the issue of autonomy, or job transformation have also some impact on the mental health of workers, increasing stress and anxiety. And in our research, we identified the impact for different levels and actors. So apart from the actual workplaces and workers and employers, also the impact that this could have for policymaking, for labor inspection, and for OSH management. And the need to have trained labor inspectors visiting the workplaces nowadays in order to be able to identify all the different risks associated with the use of these technologies. Now, when it comes to the role of regulation, currently in the EU, and it was a milestone when it was established several years ago, we have the Framework Directive that's covering occupational safety and health in every single aspect of work. But apart from this, we have several legislative provisions, directives and regulations, directives that have been transposed into national legislation, or regulations that apply as they are in member states, starting with the machinery regulation that will be put into force in 2027, replacing the machinery directive that currently applies in member states, which is set several provisions regarding the design and the use of equipment in the EU, including provisions for safety as well. And these kind of provisions could refer also, in some sense, to the different standards that should be followed, that I will explain in the following slide. Also, we are having the AI Act, which categorizes artificial intelligence-based applications in 4 different levels according to the risk of the application. We have a directive, a template for a directive on digital platform already, GDPR regulating personal data, the Data Act, as well as a number of national legislation and policies and strategies in each one of member states that is also presented in our research, identified through a survey in all the different member states. So regulation from our side is important because it could somehow ensure safety and accountability in automation by defining these clear guidelines and setting the legal requirements. Even though there may be some intersections between machine regulation, the AI Act, or some actors could identify that there are some gaps in terms of legislation, still we have the framework directive that is there in order to cover all these different areas at the workplace level. Also, transparency is very important, and the AI Act and GDPR also are important to this because all this data that are collected should be treated in a transparent way, and it is very important for this in building trust also to the technology as well as providing innovative solutions. So according to the AI Act, there are specific applications in which the use of artificial intelligence is prohibited strictly, like applications for social scoring or manipulating public opinion, for example. There are specific applications that are considered as high risk, and the use of AI is subject to specific requirements. The transparency risk category and the minimal or no risk category, where the use of AI is permitted with no specific restriction. So when it comes to standards that could also be considered as enablers, we are talking about EN standards, ISO standards, and so on, that apply to all these robotic application and robotic devices. And European legislation does not always enforce the use of these standards, but if an application or a solution complies to this standard, it is the best possible way to provide evidence that also complies to the machinery directive or the machinery regulation that, as I mentioned, will be put into force in 2 years from now. Also, standards provide some kind of a common language regarding design and implementation and allows interoperability for industrial and collaborative robots. Standards also facilitate compatibility and reliability, and standards are there on top of this also to build trust to the technology. As a general remark, and when it comes to trust and the use of technology, we have identified several cases in our studies regarding humans collaborating with robots and all these kind of humanoid solutions that were mentioned in the previous presentations, and that trust is also a kind of a thing that has to do with the expectations that the worker has from the machine. If a humanoid, for example, have eyes, it is not necessarily that the robot can see, neither if the worker thinks that it looks like a human. So the humanoid actually can sense, can hear, can see, and all these things. So as some key pointers to conclude with my presentation, I would just mention that a human-centered approach should be followed to having humans in command. When we are having specific tasks and processes to be automated, we shouldn't automate just for the sake of automation, but specific consideration should be taken before we introduce an automation in the workplace, paying specific attention on which tasks can be automated and will be automated, which tasks will be left for the workers, and how automations and workers will collaborate in order to perform the desired output. Workers should be in control of the job and have some kind of an autonomy in order to reduce the psychosocial risks associated with the lack of this. Also, that we need to develop specific tools in order to conduct this effective risk assessment, because currently there are not many tools in order to include all these different implications for us. Recently at EUOSA, we have developed and published an online interactive risk assessment tool specific to the automation of tasks that is freely available on our website. The need for training and upskilling of workers, which can be a challenge and an opportunity at the same time. That equal access to information is important, and transparency for building this trust that the system should be used for the purpose that it is designed and not for other purposes. Worker participation and consultation is a key issue in order for having the workers accepting the technology, working with the technology, and having more effective, more productive workplaces in Europe. The need to raise awareness for psychosocial risks associated with the use of technology and mental health, regulation and enforcement by the relevant authorities. And once again, as I mentioned, this kind of projects and consortiums like FORTIS, it is very important because they allow us to exchange expertise, to exchange knowledge with all these different case studies and material between EU enterprises, and especially for small and medium enterprises that lack the resources and the knowledge in order to implement this kind of solutions. And we're really happy to participate in initiatives like this. So that's it from my side. All this material is available in our website, also in our campaign website. Please feel free to visit and download all the different material, reports, policy briefs, case studies. Everything is available in there. Thank you. Back to you, Jose.
Thank you, Ioannidis. Efkaristo. It was really a good set of presentations. I have a short question for you, Ioannis, from someone that is with us. To what extent do current regulations like safety standards and certification actually can be connected directly with building trust in human-robot interaction? We are not listening to you, Ioannidis. Can you?
Yes.
Yeah, thank you.
As I mentioned, when we are having equipment that complies to specific standards, there is evidence that the equipment complies to specific rules and specifications included in there. The machinery directive that is currently in place and has been transposed into national regulation in all member states, but also the machinery regulation is not setting specific requirements as with regards to standards, but the use of standards is the best way to provide evidence that a piece of equipment complies with this. And I believe that everybody and also workers, when they can see that there is all these different compliance to standards, we tend to have some kind of more trust in terms of, for example, accuracy or reliability, as mentioned by Alessandra earlier, when it comes to the use of equipment. So regulation is clear. The need to comply to these standards can provide this evidence. So probably it is the best way to start with the bare minimum, and in order to build this trust procedure, because if reliability that could be ensured, and quality and all these things that could be ensured by a standard is not even there, how can we talk about trusting the equipment? And
yeah, I understand. Standards can be used in that way. Okay, myself, I have a couple of questions that I want to share with you. One interesting thing, to start with, Alexandra, is the following. I've also worked on trust, but in risk and risk perception and negotiation. Trust is some kind of a global word that basically we put forward, and then it's a buzzword because can be defined in a different way. For example, you define it experimentally when you put explicit implicit trust. Now, one interesting thing that I would like to comment on is it's really interesting of the role of transparency, because actually in humans, when someone is transparent, then you have an augmented trust and you have a more influence. But actually the research that you show, it's very interesting, because when the robot is transparent, then it has less influence. What is really interesting, in my opinion, is because, well, conceptually, we don't think that a robot would fail. And therefore, if the robot would fail, we don't trust it by definition. That's a first thing that I'd like you to comment on. The second point is a little bit more global, because everybody wants to put the robot working as humans. But we know that being humans, that mean cognitive biases and a lot of stuff that you described. Now, in what sense we want them to be humans? To understand that? To only have empathy and to respond to our non-verbal, or thinking like a human? It's two different things. I would like you to comment in these 2 points.
Those are two relevant points. On the first one, I do agree that the issue, the entire concept of transparency is actually more complex than one would expect a priori, in a sense that in the experiment I described, for instance, it happens exactly what you say. So when the robot explains something about its failure, it actually makes people focus on the failure that otherwise they had discounted somewhere else, somehow else. So I think that beyond, or in addition to transparency, it comes together with the alignment, if you want, which is something also that Ioannis was mentioning before. So if the robot has eyes, then it could be important that it sees through those eyes. And similarly, if the robot affords a certain level of or presents or triggers the use of a standard human-human interaction models with, by the way, it moves, it behaves, it is made, then it should be transparent about whether its perception and action will fulfill those kind of expectations. Because it can lead to very high risk, for instance, having maybe, fake eyes, but then a camera's in the feet, because as simple as that, the person that tries to fix the interaction will orient the object toward the eyes, really in practically ruining further the interaction. And this ties very nicely with your second question about how do we mean by drawing inspiration from humans. So I really think that if we want robots to be helpful to us, they need to have a model of how we think and perceive. So they need to be aware of those famous cognitive bias Because if they know where we might fail or we might over assume about their capability, then they can act to compensate exactly. So this doesn't mean that they have to share our biased view. That would be not ideal, but at least the awareness of our bias, of our problems, of our limits is really paramount for them to be able to help us compensate them. And this is where I think still a lot of work can be done.
Yeah, thank you very much. And that connects also, Isabel. You make in your presentation, and that we also are dealing with that in the FORTIS project. That is the measuring stress to the workers. One that it's a very interesting thing, but actually raises a lot of problems from a technical point of view. How should we measure it? We have several options. And then how we deal the privacy issues that raise. I would like you very much to comment and try to make some detail about those stress measures that you mentioned.
So yeah, so the stress measure, of course, it's always something which is a little bit tricky to measure. So the way it can be done is either you can do just through questionnaire, or we also develop some technology that were very close to the one you can provide in car, just to see how the attention. And that usually the trust, I think, is revealed in the fact that either, well, if you propose new technology, this is accepted or not accepted simply by the workers. And I think it's at that side point, I think it comes to what Ioannis was very saying was very interesting. You have to have first, I think you definitely need to analyze what is the work, what is the work organization, what does it do, where is it basic basic stuff, or where is the added value. And I think one again we come back to put the worker at the center. What is he doing? What is his added value? Where is it something which is very much repetitive and very stressful, asking lots of time, where it spent, and then so in all this, for instance, if I take the example of what I've done, they have really analyzed what was the work done by the operator in terms of inspection, how many hours, what was devoted to very basic stuff where at least if you have some kind of visual inspection, it's basic, it's done. Where is it focusing on really details and problem? So where is it where it is needed? So I don't have a magic board to give the answer, but as it really comes to the place where you need to understand what the operator is doing, how he's splitting his work, and where is really the experience, the things that that you get by experience, by many years of skills, and it is finally what is the core of the activity, and what that will need to be transmitted.
Thank you very much. I think, well, we are getting in the time, but I would make a challenge to Ioannidis and Alexandra. Why? Because in the classification that Ioannis shared with us about high risk and low risk and so on, mechanisms, imagine this. I consider that probably, I don't know if Alexandra already did experiments where she manipulated the aspects of the robot. Because actually what happened is that we have very nice child stuff, and we know from human psychology that a baby-like figure robot would automatically give you much more positive interactions with that. In a way, I don't know if the Alexandra and the team already did some experience where you willingly manipulate the aspects of the robots in order to get my more or less influence. In my opinion, that is the challenge for Ioannis and for Alexandra is that I would have an artificially trust if the robot is very nice and beautiful. That means that for me, a robot that is designed to give me empathy, to promote empathy, could be a high risk robot. Can you guys disagree with me?
I may start briefly.
Yeah.
Sure, there are. We actually did several experiments in which we investigated the impact of appearance and the impact of behavior. So for sure, as a function of the appearance that you give to a robot, people will arrive with a certain estimate. But I have to say that in those same experiments, we found out that even very brief interaction with the actual robot can significantly change the assumption that people, and correct the assumption that people have toward the robot. So you can subscribe that to override that to interaction. And last, there are some principles that we studied with the nice, cute robot, but then we replicated identical almost with robotic arms. So classical industrial robotic arms. So as soon as you pick the right, let's say, mechanism in terms of control, in terms of properties of the motion, and you capture that from human-inspired motion, then the effectiveness in facilitating collaboration come out both when you're using the cute ICA robot and, a Kinova arm, a newer 5, or a similar type of robots.
That's very, very relevant. Thank you very much, Alexandra. Ioannis?
From our side, I would just mention that no matter how the appearance of the robot should be, it should definitely still comply to the standards, have a CE marking in there, all these things that were mentioned regarding transparency in the algorithm should apply no matter how the robot should appear. But apart from that, it was found from our research that it is how the workers also participate in the introduction phase on this. So it is not like just introducing a robot with some kind of an appearance out of the blue. The workers should be part of the equation, and especially when we're talking about the workplace level and not, other establishments. It should be some kind of gender neutral, for example, not create, as I mentioned, any kind of specific expectations regard of the capabilities. So information to the workers should be really clear about how the job will be redesigned after the introduction of the robot, because in here we are talking about whole job redesign, to have a clear separation between the tasks that will be performed by the robot and the tasks that will be performed by the human. Actually, even in current, for example, workplaces and in a production line, imagine, for example, we don't have this kind of many humans interfering one to the task of the other. So when we are going to have this kind of collaboration, I would say, because nowadays we are talking about collaborative applications of AI-based technology in the workplace, there should be a specific consideration of the different tasks and the clear separation of the different tasks that are going to be performed by the robot and the human when they are going to collaborate in order to have a more efficient introduction of the technology and reduce expectations and improve trust.
Thank you. Well, I think that we have an incredible set of presenters and some interesting answers. Therefore, I considered my work finished here, and I will back you, Danielle, and then Florence. Thank you very much.
Thank you so much, Professor Jose. First of all, thank you for your excellent moderation and very interesting questions. And a warm thank you as well to our speakers, Alessandra, Isabel, and Ioannis. You contributed with very inspiring presentations, your studies, Alessandra, as well as Isabel's inputs from Yarashi and Ioannis as well. It was a great opportunity to learn a little bit more from you. Before we close, we want to let you know that the recording will be shared shortly. A short feedback is shared on the screen and was also shared via the via chat. It only takes 2 minutes, and your feedback is valuable for us to improve future webinars. On behalf of the FORTIS project, thank you so much for joining us. Stay tuned for the next webinar in this series, and we wish you a wonderful rest of the day. Stay tuned so you know when the next topic is up and who the next speakers will be. Thank you so much and have a nice day.
Thank you. Goodbye.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.